Hello. So again, welcome Chem 222 class. This is for our lab this week, our kitchen chemistry for half of the lab. So remember, the lab this week has two parts, and the one part is got protein. So that is Arnold, and that's protein, which is quite the myth. This is definitely a myth busted. Um, of how much protein and what your best source of protein is. And this is everything to do with intermolecular forces, by the way. So there's a relationship. So I know you're all too young to remember this commercial from back in the 80s, but right, it was a Wendy's commercial that these three beautiful women were saying, "Where's the beef?" You can see, I don't know if you guys know what that is. That's actually a phone cord before we had cell phones. But what is behind them is this beautiful picture, which is legumes. And so this is also to inspire some of you. If you haven't started with your healthy change, it's not too late to start eating legumes every day. We're supposed to every meal. Mine today had what's at the top of the screen, which is the pinkish red lentils. They're my favorite. But legumes every day, and your microbiome will be so happy. So you make that your healthy change for the 30 days. Why not? What do you have to do? Because we're not going to school. You have all that extra time. And so the real question is, do you really need to eat meat to get protein? So it's been a fascinating week because there's been a question if we're going to have a meat shortage. And so people are starting to hoard meat, right? And so, oh my goodness, where would we get our protein? And protein is an interesting term in itself, but actually vegetables are a perfect balance of the nutrients besides the macronutrients of carbohydrates, fiber, which you get none in beef. It also, that color tells you that vibrant green color, it's packed with plant nutrients. And there's so many different ones and so many different ideas of topics. So this is just from the Give Project. So top nutrients, 10 sources of veggie protein nutrients versus in meat and eggs. So yes, you're also, yeah, eating vegetables. Eat green, eat the rainbow every day. Red cabbage, I make a salad and has pretty much all the colors. Blue's a little hard to do. And if you've never seen the movie The Game Changers, I have never seen it, but it is about most world-class bodybuilders are actually plant-based for many reasons, but this was the strongest man in the world. And there's actually stories of so many professional players who also, and they don't want anybody to know, not because of a stigma, but because they have an advantage. They have more stamina, and they don't want the other athletes to know the advantages that they've gained because it gives them an advantage in the games when they play. Nuts also are a wonderful source of not just protein, but also fiber and other nutrients. And there we go. You guys are all Toy Story remembers. So there is everywhere in the plant world lots of protein. But that's not what our lab is about. But we're going to talk about proteins because they are in your lab. Proteins are made up of amino acids. And so they have the amino end here and they have the acid end. And there's a carbon here in the middle. And this group here varies. And this is what part of your lab is about. And that's why I'm making this slideshow. This picture actually shows amino acids correctly. Almost everybody draws them incorrectly. And that is because in our body, they are actually ionized. So the nitrogen actually picks up. Remember those two dots that we were always showing? This nitrogen does not have it. It actually has a fourth bond, and so it has a hydrogen here, which makes it an ion, a cation. And the hydrogen that normally would be here on a carboxylic acid is actually, it has donated that hydrogen. And so this is fully ionized, which makes it extremely hydrophilic. And there's about 20 different groups, and they form these long chains that we call a polymer. And wouldn't this be wonderful again when we're allowed to hold hands? Now, something I keep talking about, your shoulder is a covalent bond to you, right? These hands, though, are the attractive forces. and when we release them, they will come apart. And we're going to talk about the attractive forces. So these are the 20 different amino acids. What's highlighted in green is the R group. So these top ones here in the green, their R groups are only made up of carbons and hydrogens mostly. And so they are considered non-polar side groups because, or hydrophobic, or we would say London or induced dipole attractive forces. They don't actually have attraction. They just don't like water. These here in the pinkish purple, lavender, lilac color is they have oxygens or nitrogens, or look, they have OHs. So they are called polar, and they're going to make H bonds. Because when you see OHs or NHs, now the backbone is up above. That is the same for all the amino acids. That's going to do something special. Down here we have ones that are considered acidic. They gave up that hydrogen. So they have this extra carboxylic acid group. And then these have extra nitrogens, so they're considered basic. So extra nitrogens are bases. These up here, the nitrogen is attached to a carbon that has an oxygen, and that oxygen is so greedy, this nitrogen can't behave as a base. So don't worry about that. This chart, I don't ask you questions like that. All right, we're going to walk through these different levels of protein structure because this should help you hopefully be able to answer some of the questions in the lab. So the first level of structure is, oh, these are all lines. This is all covalent bonds. And this is when we hook one amino acid to the white amino acid, to the blue amino acid, to the orange amino acid. These other levels are what's going to give us a 3D shape to our protein. And those are all going to be based on attractions like H bonding or dipole, ionic even. So they're attractive forces. So the first level is covalent bonds. These are the peptide bonds, and that's what makes them a peptide. So insulin was the first one that was sequenced, and this just shows the different amino acids, and they're all different sizes. Yeah, I had a student one year did a really cool paper on hemoglobin. Insulin is cool too. It's just such a big topic. I don't usually recommend it. But there's some other really cool proteins I've had people pick as their topics. So the secondary structure was discovered. This guy's one of my heroes. You've heard me mention Linus Pauling. And yeah, so the dots are the attractions. So the nitrogen has this hydrogen sticking, and we see dots. That's hydrogen bonding to the oxygen. So anytime you have an H attached to NOF, an N or F, that H is going to have a positive area, and it's attracted to another NOF on another part. This is interesting because they're not discrete molecules. They're on the same long, gorgeous chain. And it happens every third one. And Linus Pauling figured this out and won a Nobel Prize. So we see this regular, and we see these alpha helices. So if you've ever noticed, I have curls. Some of you do too. And so we have these beautiful alpha helices that show up. This is an interesting picture. This is an alpha helix. There are also what are called beta sheets, which are these repeating, going back and forth like that. And this is a picture of a prion, which is another interesting. It's a kind of the downer subject to pick. But prions, these exist naturally in our brain, and something happens and changes all these beautiful alpha helices to a beta sheet. And then they all change, and they can never go back. Never. None of them ever fold correctly again the rest of your life. And you end up with holes in your brain. And so that's what mad cow disease is. And you go crazy. Well, you don't go crazy. You just don't remember anything. So this is just Linus Pauling. That's his wife. He gives so much credit to her. That's him lecturing with all his awesome, huge models. Now we just do everything on the computer. He is one of only 2 people to win 2 Nobel Prizes. His second one was the Peace Prize for his organizing marches for against nuclear testing. And this is just an example of the alpha helix. So actin and myosin are in muscles. They're also in your feathers, so, or in your hair. So on your best hair day, you can think about your alpha helix, whether you're showing your curls or not, or whether you're showing your muscles or not. And that's an example of a beta sheet. Again, dots show dots up here are showing the hydrogen bonding. This is a cool topic. I had a student do this one year, was silk. Silk is a protein. It's lightweight, flexible, and soft, and it's actually very protective. Strand for strand, it is 3 times more flexible than Kevlar, and it's 5 times stronger than steel. And so there's a type of silk that is actually better than Kevlar, and it's not so heavy. And so they're starting to make a lot of the bulletproof vests out of this. And so it can absorb this huge amount of energy. But spiders, they don't play nicely. These spiders attack each other. So they couldn't farm them. And so what they did is they actually spliced the gene into silkworms. And the silkworm actually plays nicely. And then there's some really weird stuff. They also spliced the gene into a goat, and then they milked the silk out of the goat. I don't have a picture of that because I found it a little, well, more than a little odd, but you can Google it if you're thinking there's no way. But if you want to be a superhero, you can start breeding silkworms in your free time. All right. Silk is pretty cool because it's biodegradable. So just imagine all these things, right? We wouldn't have the issue with all this debris everywhere. Parachutes, tendons, when we replace somebody's has a torn tendon, sutures, you know, and poor Spider-Man and all that kind of stuff. I already mentioned prions. So this is a normal brain over here on the left, and this is somebody who's got prions. There's lots of holes, and that's not a good thing. But I will tell you this, so this is the healthy brain, which would go over here with the purple one, and this is the unhealthy brain. It looks a lot like when people are eating a lot of sugar too. If you want to do a downer presentation, pick prions, or if you want to pick a really fun, inspiring. All right, so where we're going with this, which has to do with milk, is there's something called a tertiary structure. And the tertiary structure is the overall 3D look of the protein, and the shape of the protein determines its function, how it folds. And I'm skipping through these because that part's not important. This is the part we need to know. So the overall 3D, I made the same slideshow for my 2 classes, and they need to know some more of these details. So there is these actions that are going to happen. This blue ribbon is the backbone. The amino acids all covalently linked together, which is this ribbon. And then there's interactions of those R groups are sticking off, and you can get 4 different types of interactions. This first one's actually really special because it's a disulfide bridge. It is covalent. That's why they're showing it as a line, and it only happens with cysteine. This first one, by the way, there's tons of it in your brain. And we're going to get to a slide in a few minutes where that becomes important. The second one is called a salt bridge, or ionic, or electrostatic. So those positive and negative, the acidic and basic, whenever they fold near each other, you get this attraction, which is strong, but it is just an attraction, so we can jiggle it apart. And then this will be our H bond. So these will be the polar ones. And these guys are not actually attracted. Notice there's no dots. They actually are hydrophobic. They just don't like water. And since you and I are 71% water, these guys are always hiding. So in the folding of our proteins, they're going to fold so they're in the middle. So they're nowhere near the water. They're always hiding. So it's not that they're attracted, it's their fear. So like in these, they would be in areas that are deep down inside. And all of these are just different proteins. We have thousands, tens of thousands of proteins in our body, and they each have a unique folding, and they each have a unique purpose. Like this looks like a little Lego guy. This one's a receptor. So out here would be on the outside of the membrane, and it's probably an insulin receptor. Insulin would bind here, and then it causes a change. And then you get some like hemoglobin where you have 4 units, pretty large. All right, so again, it's primary importance because it's covalently linked. And then we can get silk, again, cool topic. Keratin and collagen, more cool topics. Tertiary structure, quaternary structure. So that comes up. You're going to hear me say these words. So what this has to do with your lab. Your lab is about hydrolysis versus denaturing. So the word hydrolysis means water to cut. And this happens in our body by what are called proteases. So they're eating, the proteases are eating and chopping this into individual amino acids. So we're cutting. The problem is, from the previous picture, our proteins are these big balls. They get made, and so it's really hard to cut a big ball. We can see the cat, he's trying to play, but he can't get it cut very well. He's just making a mess of it. And so this little kitty's much smarter. Before we go through hydrolysis, our body actually, this is why your stomach does the gurgling stuff, it has to denature the protein. And so what happens in denaturing, you still have the covalent linkages, so the peptide bonds, the primary structure is still there, but we lose all the beautiful shape, all those hydrogen bonds. The hydrophobic is no longer there, and we're going to see why. And so he's not doing, he's trying to unwind this whole thing. All right, so this is one part of your lab that you get to do in your kitchen. How can you denature proteins? This has everything to do with intermolecular forces. So you're going to need one raw egg, and you're going to denature it in a couple different ways. So you can shake it or jiggle it or just get a fork. So you're going to have to separate, first of all, the egg whites from the egg yolk. So if you don't know how to do that, you're going to learn. It's really a great trick. You should know how to do it. Joey's been able to do it since he was like 8, because I was just like, Joey, you need to know this, because I never learned until I was much older. All right. And so then you take that one egg white, and you're going to split it into 6 containers. So one of them you will jiggle however you want to jiggle it. And so, and then you're going to have to explain to me why it works. Well, if you're jiggling it, you're not going to break the protein bonds, the peptide bonds, but you're going to jiggle apart the attractions, the hydrogen bonds, and the ionic electrostatic attractions. Oh, you could be, if you got any mercury around, you could try mercury. So in lab, we don't use mercury, we use silver. So if you have colloidal silver in your home, you could actually try that. But what happens is mercury, silver, and lead are pretty awful. So they were called, they're the Mad Hatter, because hats used to be made out of felt. And to make the felt come out just perfect, they would use mercury. And so all the hatters became crazy, because mercury, silver, and lead bind to sulfur. They love sulfur. And if you remember from the previous page, sulfur made those disulfide bridges. And those disulfide bridges hold the protein, keep the tertiary structure, and there's tons of them in your brain, in the receptors in your brain. So if you think about where all your mercury fillings are, the amalgam fillings, people are like, no, they're silver. Mercury. They're right next to your brain, and it does cross the blood-brain barrier because the bacteria in your mouth makes it into methylmercury. That would be another good downer topic. Give you guys all good downer topics if you want to be like a downer on this. One of the things you're going to use is alcohol. So you probably have isopropyl alcohol, or hand sanitizer is pretty high in alcohol. So you'll just squirt a little bit of that on the egg white in its container. You can also use vodka if you have that in your house. I don't think this gnome selection is going to work so well because it's not a very high alcohol content. You're going to also use an acid of choice. So the way the alcohol works is it's going to be attracted to the H bonds. So it's going to pull the H bonds apart. The way the lemon works is it changes the pH. So back we had those ones that were acidic and basic that had a positive and a negative. And this is going to fill in the hydrogen. So it's no longer going to have a negative. And yeah, you're not going to actually pee on your egg. You're going to squeeze the lemon on there, or vinegar, or whatever acid you have. I have other choices in the next slide. This is whatever type of soap or detergent, and actually write down what you use. What we use in lab never seems to work because they have the cheapest stuff. So detergent probably will work better. And detergent works because it has a hydrophilic and a hydrophobic part. And so that hydrophobic part is attracted, and it makes that those non-polar parts of the amino acids think it's safe to come out and play. And so they come out from their hiding and the whole thing unfolds right in front of our eyes. Oh, and of course you can cook. So heat is going to just jiggle. So it's just going to jiggle enough that the H bonds come apart, and the H bonds are a huge attraction that holds it together. But again, it is just an attraction. So all these things can disrupt the attraction, but what happens is it's just denatured. It is not hydrolyzed. So in our body then, this is our stomach would be churning and churning. So the other part of this lab, so again, this is just half of the lab, so 1/4 of the lab is doing the eggs and then talking about that and then doing the milk. So this does have to be cow's milk because it has to be the casein, is you are going to make milk curds. And so I realized I can't use, I have all these pictures, but since unfortunately this is getting posted online, I can't have anybody in the pictures but me. So, and Joey, because he has my permission. Well, actually, he doesn't need my permission anymore, but anyway, there you go. Wear your safety goggles. You don't have to, but you can. All right. So you're going to make, I did this with the kids. So your milk is actually mostly water, but it does have these proteins in it. So we're going to talk about these proteins because that was what the title was, got protein. So what are the proteins in milk? Well, most of you remember Little Miss Muffet, found her tuffet. And what was she eating? So that's her tuffet. She was eating her curds and whey, and that's what's going away here. And so the curds, oh, this is a protein. This is what jiggling and wiggling and stuff will overcome, but we're not going to jiggle and wiggle this. This is, if you've ever been to the Tillamook Cheese Factory, the most visited place in Oregon is the Tillamook Cheese Factory for the squeaky cheese. And bodybuilders, they just say, hey, I gotta have my casein. This is Joey. 10 years ago, we went to the cheese factory high in the Himalayas. And so this is actually in Nepal. This is a copper pot. And they called Joey their little brother. And they just wanted Joey to help them to make the cheese. And we stayed there for a couple days, and it was really fun. Casein is used to make cheese. That's why all these pictures are there. It is the cheese. And we're going to talk about that in a moment. It is also, I believe, the bristles in paintbrushes, brushes, and toothbrushes. It is also in whipped cream. And there is a reason there is the cow on your glue, on Elmer's glue. That is casein is what is used to make glue. And, of course, cheese, all types of cheese. So most of you know about lactose intolerance. That's not actually the problem. You are all casein intolerant, and it's beyond intolerance. Yeah. So cheese. So when you tell people to give up dairy, they go, okay, I can give up my milk, maybe even my ice cream. You're like, but can I still have cheese? Like once in a while? No. It's the cheese that's a big culprit because cheese is really high in casein. Casein, the protein, the structure of it, the sequence of the amino acids is actually really hard for our body to digest. And it has to do with how the proteases, once it's unwound, it's really hard for it to cut it correctly. And so you end up with excess phlegm and respiratory problems. And in this day and age, our milk has been altered even more by ultra homogenization and even higher heat, which has changed the curds. And that's why the spider did not mean to scare Little Miss Muffet. He was just trying to warn her that maybe she shouldn't be eating this. And so because the protein cannot be fully digested, we end up with a lot of digestive problems that get blamed on other things. Constipation, gas, bloating, diarrhea. I would bring in here, yeah, pretty much all those skin issues. And in case you didn't know, casein is an opioid, just like heroin, just like morphine. And you become addicted. And that's why people don't want to give up their cheese. Oh, there's much more to casein. So Mama Cow isn't very happy with me, but Anyway, you can do your topic. If you're like a cheese addict, why don't you do your topic on cheese? Or all of you give up cheese for 30 days and then go back to it and then say, so for all the girls in the class, most menstrual issues will be completely cleared up in the first month if you give up cheese. It just goes away because this is a huge culprit. All right. So, casein, how about the whey? This guy's having way too much. But again, this is showing you tertiary structure. And in lab, which is the next slide. So after the milk's curdled, casein is removed. So that's what you're going to do. And we're going to actually throw away the whey. The whey is going to end up in liquid, and you're going to strain it out. And that's its name. Maybe you like love whey too much protein, and you want to look into this to see, oh, is she telling me the truth? So your topics are worth a lot. You want to pick something, and you're going to need to really get into it. Isaac's already, no matter what he picks, I know he will do an amazing job. But look at both sides. Go into the dark side. Maybe you'll learn something you didn't. And so this is why bodybuilders love to take whey protein, because muscle hyper means big muscles. So studies suggest vigorous exercise and taking whey protein can help you to be bulked up. I don't know. It's high in certain amino acids, blah, 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 blah. Oh, and then that little note they always say at the end before the commercial ends, oh, but it is linked to cancer. So let's explore that for a minute. There is, I don't know anything about this guy, and I am blanking on the name of the person right now, but after World War II, Japanese men saw a 25-fold increase in prostate cancer. Not a 0.25%, 25-fold increase in prostate cancer. And what happened during this time was suddenly we were there, and we were helping them to rebuild, and we were helping them to rebuild by telling them, hey, you should eat eggs and meat. And so these men were now eating 7 times as many eggs and 9 times as many meat as they used to. And holy cow, look at that. It's almost the exact same amount as the prostate cancer increase, the amount of dairy they were consuming. So in this experiment, they dripped organic cow's milk. They decided to take the organic onto prostate cells in a petri dish, and they repeated it 14 times, and they always saw about a 30% increase in cancer cell growth. They did the exact same experiment with milk, and that was from almonds, just to show it wasn't the procedure. Oh, and it was fascinating. The almond milk actually suppressed the growth of the cancer cells. All right. And then there's this huge study, a meta-analysis is where they just look at all the studies that have been done, and it confirmed there is a huge link between dairy and cancer. Whenever you see anywhere the top anti-cancer foods, there is never an animal product in there. Look at there, there's those mushrooms. We should all be eating mushrooms every day, broccoli. Yeah. You pick one of the compounds in one of these and have a wonderful topic. Pomegranates, I'm not a fan of dragon fruit. All right. So how did Little Miss Muffet's mom make curds? Or you, her lab partner is what I should have said. So the casein forms these micelles. So these are large aggregates of molecules. And if we drop the pH, what's going to happen is it's going to unravel. And what's the word? It denatures. So it goes from this beautiful micelle into where it denatures. And it comes out in clumps like that. So this is what should happen to your milk when you do this in your kitchen. And just like this, you're going to have to take a picture, and you're going to have to embed that picture into your lab report. You can all do it. You can figure out how to do it. All right, the casein denatures. And that's how cottage cheese and sour cream are made. And yeah, if you don't want to try your cheese, your cat will love you. When I do this in lab, only it depends on the lab. If the students have been with me previous terms, they always eat the cheese. And if they're new to me, they let me take the cheese home, and my animals are so grateful. Or I make plastic dice. So we did this once with the kids class. And this is for real. Could not make this up if I tried. From the early 1900s until 1945, milk was commonly used to make plastic. It was before the evolution, before we figured out plastic, which, by the way, would be wonderful topics. There are so many different types of plastic. Kevlar would be a wonderful topic, or silk, but any kind of plastic you could pick to do. And there's lots of research on them. So remember, in your topic, you do have to find two scientific research studies and have a good solid paragraph at least on each study and discussing it in your own words. So anything from buttons to fountain pens to the backing of mirrors was made from milk curds. And that is the Queen of England. They actually made jewelry for the Queen of England out of milk curds. So if you don't want to eat your milk curds, you can make some jewelry for your teacher as a farewell present. You leave it in my mailbox. This is the guy, if you go to Buckingham Palace and take a tour, this is the guy making her jewelry. We all thought they were pearls, but turns out they're milk curds. And this is me. I took it a step further down there in the basement. This is back in our chemistry lab. Do you guys recognize it? I actually took it a step further, and I made it into glue. So you make the curds, and then you can make it into glue, and then I made it into flubber, which is silly putty. And so the Queen actually loved silly putty. None of the kids would get their hands messy, but I had no problem with it. So skim milk, yeah, skim milk just means it's more watery. And 3 years ago when we did this experiment, the skim milk did not work. It did the past 2 years, so it made me wonder, but what are you going to use? So you have to use something that changes the pH, something that's acidic. So I will tell you what, the Pepsi and Coca-Cola, we could not get them to work. We poured the whole can in, and we could not get it acidic enough. So that also did work 3 years ago, but it doesn't now. So something in the formula has changed. You can use oranges. You can use lemons. You can use limes. You're going to do it 2 times. You have to use 2 different things. Red Bull absolutely works. Any of the energy drinks work. You don't have to add a lot. You will have to add more than of the orange, but it is really gross. It will curdle it, and then you can make it into a dice and take a picture and send it to me. Those are cranberries, cranberry juice, apple juice. They also work because they're pretty acidic. You will need more than you would of the orange because they're not quite as acidic. And I will tell you this, my students who make it with the cranberries, that ends up being their favorite one for the taste. Vinegar is the other choice that gives you. So eggs, we already talked about this, that you're gonna try to denature your eggs, but just real quick, if you still need an inspiration, I think this is, we're getting towards the end, that there was a study at Harvard on early stage prostate cancer that men who ate 2.5 eggs per week, they had double the cancer progression, meaning it metastasized to their bones. There's the reason the barbecue guys are there. 81% increase in mortality. 81%. Not quite double, but that's pretty significant. There was only one thing that was worse than the eggs in promoting prostate cancer. Oh, that's why the chickens are there. Yep, it was chicken. Chicken was 4 times worse than the eggs. 4 times. It has to do with these. This is the question Janae had asked me. And these are all fun topics. So it has to do with chicken or eggs. Animal protein is really high in these. Heat from cooking forms them into this, and that is called a heterocyclic amine. So hetero means different types of cyclic compounds, and there's nitrogens or amines, and there's a lot of them in poultry meat, and it has to do your liver and detoxing, that it actually promotes cancer, all different types of cancer. Grilling mussels actually biggest problem with growing muscles has to do with the amount of sugar in the barbecue sauce is going to also cross-link to this. And so that's going to create advanced glycation end product, which is going to exacerbate this. So your body, so plant protein doesn't have these. And so you don't have the same problem. So eat vegetables. All right. Oh, that's my dog who is smaller than my kale. So this is the kale from my garden, and it is like the size. This is what we have every morning in the smoothies, and it's wonderful. It just comes up wild. So in case I haven't convinced you, what are the problems with a high protein diet? What is Sherpa going on about? So in case you haven't picked your healthy change, or you kind of thought you did, or you want inspiring for the month, well, the average American gets double the recommended. We actually probably get 4 times the amount now because everyone's going crazy and saying, oh my God, I need protein. Protein acidifies the blood. We're going to talk about this more again this summer. This is your blood on acid. This is your blood on vegetables. So acidic means you're eating meat and processed food, sugar. Stress causes this, smoking. This is what we want. So acidic blood means a pH around 7.2. Alkaline blood means pH around 7.4. Yeah, and so it pulls calcium out of your bones. It leads to osteoporosis, fractures, and arthritis. And cancer cells only live at a pH of 7.2. They cannot live in alkaline blood. High protein diet, animal protein diet, acidifies your blood. So remember the barbecue sauce? You're like guaranteed to be down here. Oh, and you're also exposed to toxins, so antibodies, growth hormone, pesticides. That was the nicest picture I could show of how cows are treated, which is not humane. All right, this guy, T. Colin Campbell, is another one of my heroes. He did one of the biggest studies ever about 17-fold increase in heart disease, looking at the United States, at Oxford, and then rural areas in China. And the rates of heart disease and all different types of cancers. And another big one is, so protein is really high in nitrogen. And the only way your body can get rid of the excess nitrogen, because there is excess, whether you're taking it as whey, as a supplement, which your body can only use so much of it, you have to get rid of all that nitrogen. And it's your kidneys that get rid of them. And it has been known that high protein diets destroy your kidneys. In fact, that's why the paleo fad is no longer in. After 5 years, so many people had kidney issues that they had to start saying, oh, don't do that. All right. Oh, and then you won't poop. So you'll be constipated and grumpy. Oh, and then that whole keto thing. They leave out the word acid. It is correctly called ketoacidosis. So yeah, which weakens your brain, your kidneys, and your red blood cells. Look like that. Cancer likes that, apparently. Healthy cells like this. Also destroys your immune system and destroys your microbiota. Your intestines, half of the cells in your body are bacterial, and they would love to eat fiber. They do not like animal-based food. Okay, I was going to say, did I say you can never have bacon again? Oh, yeah, you should not eat bacon. You might as well just eat cigarettes. You might as well just go and lick plutonium. Just go down to Hanford and just start licking the ground there, because they are all class 1 carcinogens. And it's not just bacon. It's all the highly processed meats are actually classified as class 1 carcinogens. Guarantee they will cause cancer. So those are the free radicals. All right. This was a book I never got a chance to read, but it just looks at, it was a guy who was a doctor who was really into eating meat, and then he found out his blood work wasn't very good and the connection. And my number one reason, all of these are equal in my heart, is that Mother Earth cannot handle the diet that we eat. So why not give up meat for 1 month, 30 days? Everyone would be so grateful. including Mother Earth. And that's all I got. Good night. Pleasant dreams. Have fun experimenting in your kitchen. Can't wait to see the pictures.